So for my physics video, I was given a dolphin problem, and it states, a dolphin in an aquatic performance jumps straight out of the water at a velocity of 14 meters per second. And then for part A, it asks, how high does his body rise above the water? 3 meters. And so first what we're going to do is list the knowns. So we have the initial velocity, which is VI, and that is 14 meters per second. And then final velocity, which is VF, is going to be 0 meters per second. And then G, which is gravity, is always negative 9.8 meters per second squared, which is also the acceleration units. And so what equation we're going to use for this is the kinematic equation, which is represented by the formula x equals the final velocity squared minus the initial velocity squared, all over 2 times the gravity. And so what we're going to do is plug our knowns in to the equation. And so this is going to give us x is equal to 0 squared minus 14 squared, all over 2 times negative 9.8 meters per second squared. Sorry, let me put units. Meters per second. And then when you plug this in, you're going to get x is equal to negative 196 all over 19.6. And it's going to be negative 19.6. And the units on the top are meters squared over seconds squared, and this is meters per second squared. And so you're going to divide this, and you're going to get x equals 10 meters, because seconds squared is canceled, and meters squared divided by meters is just meters. And so that, oh, you can't see it, but that 10 meters is how high the dolphin's body rises above the water. So just remember, using the kinematic equation, it's final minus initial, and each one is squared and then divided by 2g. Where it can be confusing is just remembering it's squared and remembering it's final minus initial. And then for part B, it says, how long is the dolphin in the air in seconds? And what we're going to do for this one is use the equation time. Well, this equals VF minus VI all over G. And that's going to be times 2, because this is just for going up, and then we also have to count for going down, so it's going to be double, which for me was the confusing part, is where you might not remember to multiply by 2, so it took me a little bit to remember always multiply by 2 if you're looking for the total. And so we're going to plug in using what we previously had. So VF is going to be 0, and then VI, this is meters per second, 14 meters per second, all over negative 9.8 meters per second squared. This is going to be negative 14 meters per second, all over negative 9.8 meters per second squared, and then I'm going to divide. That's going to leave us with 1.429, and don't forget, multiply by 2 to account for both up and down, and that is going to give us 2.857 seconds. So just remember, the first one on part A, you're going to want to remember this kinematic equation, v squared, our velocity final velocity squared minus initial velocity squared all over 2g. And for part B, to find time in seconds, remember that you're going to have final velocity minus initial velocity divided by gravity, and all that multiplied by 2 to account for both up and down, which can be easily forgotten, so don't forget that too.